So that is the probability distribution that we have, which is the number of chicken wings that a person would order if they went to a restaurant. And if that is the case, the probability that a person will not order chicken wings would be 0.2903. Yes. That would imply the probability the person will order chicken wings would be equal to
1 minus that.
1 minus that. Good. 70% chance. Very high. What I'm going to do is I'm going to call this one P. And that's a big Q. Good. So there's a reason why I'm doing this. P and Q. But by all means, Q is 1 minus P, right? So 1 minus 0.7097 would be 0.2093. Here is a scenario that I want you to consider. Look at this three. So we know this probability from last time. You guys gave me the data. We came up with this. So we know P, which we know Q. Based on this, let's say 3 students go to a restaurant, and X is the number of students who order chicken wings out of the 3. And we're going to assume no peer pressure in the sense just because one person ordered chicken wings doesn't mean the other 2 are going to also. That's it. What are the possible outcomes for X?
0, 1, 2, 3.
Very good. 0, 1, 2, 3. None of the 3 ordered chicken wings. Exactly 1 did, or exactly 2 did, or exactly 3 did. So just like the television problem, I can find the probabilities for each of those outcomes. Do you agree? So the table in the previous case was 0, 1, 2, 3. That referred to the number of televisions per household. Here, we're referring it to the number of students out of the 3 who would order chicken wings. Good. So, on this, I can erase that. With each student, what are the possibilities? Just, going to the restaurant. In terms of chicken wings, what are their choices?
0, 5,
That's the last point of this one. Here we're just saying whether the person's going to order or not. So what are the choices for a student?
Yes or no?
Yes or no, right? You either order chicken wings or you don't order chicken wings. So the choices because X is going to measure the number of students who order chicken wings. I'm going to say, well, if the person ordered chicken wings, then it is a success. That would mean not ordering a chicken wing would mean unsuccessful. Simpler word for that. Simpler than that. Failure. So, failure. So, we have success, we have failure. With each student, there are only two possibilities, success, failure. And I made this very clear in the statement as to no peer pressure, and I also explained what that means. So can you relate that to something that we know in probability? It is a property of events.
Random.
Not everything is random.
Exclusive.
Oh, close, but wrong. Very good. Independent events. So person one, the exclusive cases for addition, but they can't happen simultaneously. So person one's choice doesn't depend on the other two. Person two doesn't depend on the other two, and so forth, which is why I put that statement in as no peer pressure. Okay, deal with the statement. I'm going to call the student as a trial. Good. So how many trials do I have? 3. And what is the probability of success? So 3 independent trials. P is the probability of success. I have defined the success event to be ordering wings, and I know that value 0.7097. Naturally, if the probability of success is 0.7097, the probability of failure would be 0.2903. Good? Okay. Going to erase this. So my goal now is to come up with a distribution. Those are the possible values of X. And we want to find the probability for each of these. This particular distribution has a name. It is binomial. What does bi mean? That's it. 2. Y2, we have 2 outcomes. Yes. What does norm mean? Number, name, attribute. So we have 2 choices. So this is a binomial experiment. Good. So for something to be a binomial experiment, we must have 2 choices. The trials must be independent, and you know the value of B. Those are the requirements. So 2 choices per trial, or in this case, per student. The trials have to be independent of each other, which in this problem they are, and the probability of success is known. We have that to be 0.7097. How do we find this probability?
Wait, so what is it called?
Uh-oh. Okay. That is a binomial experiment, and this table is a binomial distribution. So we want to find the probabilities the first case simply means none of the 3 students ordered chicken wings, right? You know, if I have to put it in words, all I'm saying is the first student did not get chicken wings, the second did not, and the third did not. So what rule should be used to find the probability? First one did not, and second one did. Multiplication. Okay, so 3 students, first one did not, second did not, third did not, right? Those are the possibilities. Can you think of other possibilities, or is that the only way in which none of the 3 students would order chicken? That's the only possible way, correct? The first one didn't, and the second didn't, and the third didn't. So the probability that a person would order chicken wings is 0.7097, which would mean doesn't order. We know that probability, it's 0.2903 multiplied to itself. Good. So there is only one way for that to happen. I'm going to put 1. The probability of success is 0.7097. But how many successes do we have in that case? 0. So I'm going to raise it to the power of 0. And how many failures do we have? 3. But just for fun, I'm going to write as 3 minus 0. It's not just for fun. There is a reasoning, but there is the reason behind it. Good. The second case, exactly 1 out of those 3 orders chicken wings. So in how many ways could that happen? 3. What are the 3 ways? Can I make this one? Go ahead, Sam.
Oh, the first person gets them, the others you don't. And the second person gets them, the others you don't. And the third person gets them, the others you don't.
Yes. Can you think of any other possibilities for the 3? No. So I have a success probability and 2 failure probabilities. Correct. So 0.7097, 0.2903 multiplied by 0.2903, which is 0.2903 squared. Basically. Now, would these probabilities be any different from that one? No, they're exactly the same. So either this is going to happen, or that, but they can't happen simultaneously. Do you agree? If I give them names, say Matthew, Phoebe, give me a name. Rob, okay. So if I say Matthew was the only person who got chicken wings, I can't also say that Phoebe did and Rob did. At any given time, only one of them could happen. So that property is called What's the name of that property? At any given time, only one of them could happen. Now is your chance. They are mutually exclusive. Okay.
I was thinking independent.
So one success and two failures. So 3 minus 1. And in how many ways did it happen? 1, 2, 3. So I'm going to click through. Good. X is equal to 2 would mean 2 out of the 3 people ordered chicken wings. So in how many ways could that happen? So what are the possibilities? If I said 3 people walked in and exactly 2 of them ordered chicken wings?
6.
6, okay. 3, Sam, what are they?
The first two, the last two, and the first and last one.
That's it. So 3 possible ways. What is the probability? You have 2 success probabilities. 0.7097 multiplied to 0.7097. So we will have 0.7097 squared. How many failures do we have? Exactly 1. 1 failure probability, 0.2903 raised to the power of 1. And in how many ways does it happen?
3.
1, 2, 3. So 3 times 0.7097 raised to 0.2903 raised to 1. I'm going to write that as 3 minus 2.
Can you explain what time are you writing is 3 minus 2?
Why? I'm going to get there. So, lastly, x is equal to 3 would mean all 3 of them ordered chicken wings. So in how many ways could that happen?
1.
3. 1, exactly 1 way. Matthew did, Phoebe did, and Rob did. That's the only possible way. So 1 way of happening. How many successes do we have? 3. So the success probability is 0.7097. You multiply that to itself 3 times, so we have 0.7097 cubed. Are there any failures? None. So I'm going to write it as 3 minus 3. Good. We can find the values. What are they in decimals? Do you have it? What are they?
0.0245. 0.1794. 0.4386. 0.3574. Somebody double check.
That's it. 3 times 6. Sounds right to me.
Thanks.
Okay. We have the outcomes, we have the probabilities, just like the previous problem, right? Number of television. So we had 0, 1, 2, 3, and we've got the probabilities. Is that left skewed or right skewed? What? Left skewed, because majority over here, and then few on the other side, it is left skewed. If I asked you, take a guess on the average, what would that average be? The expected value. If 3 people walked into a restaurant, and if this is true, how many out of those 3 would order chicken wings? Approximately 2, right? The average is going to lie somewhere here, and the chances are it is going to be closer to 2 than the 3. So rounded to the nearest integer, 2. Great. Now, Sophie asked me, why did I do that? Sure, we used multiplication rule to come up with the probabilities. Logically, I put checks and crosses to determine the number of ways in which each of those could happen. I was able to do that because I had only 3 people. Imagine 30 people walked into a restaurant, and we would like to know the probability that exactly 20 out of those 30 people ordered chicken wings. Do you really want to sit there and put check marks and cross marks? No, it is not easy. So let's erase this. The first part, the number of ways in which an event could happen. Given, that's just a formula for probability, x is equal to sum x. Your calculator has this as NCX. I'll show you how to get to that. NCX stands for N choose X. So why do we call it choose? We have 3 people, and out of those 3, we're choosing those who ordered chicken wings, right? None, exactly 1, exactly 2, exactly 3. If we use this formula, we can find those numbers. Where does it come from? Pascal's triangle or binomial theorem. I won't guess it. Okay, so each of those, they are just the value of p. Do you agree? Yes. So I'm going to put p. When x is 0, I get 0. When x is 1, I get 1. X is 2, 2, 3, 3. So if I put an arbitrary x, what should the power of p be? X. 0.2903 is failure, 1 minus p. I can call this q, right? That's how I started. So q. How many trials do I have? N is 3. Minus. When x is 0, I have 0. When x is 1, I have 1. When x is 2, I have 2. X is 3, I've got 3, so what should I put here? X. And that formula is simply the formula for a binomial distribution. So if I wanted to answer that question, 30 people walked into a restaurant and we want to find the probability exactly 20 out of those 30 ordered chicken wings, all I have to do plug in n equals 30, x is equal to 20, and I know these 2 values. Yes, plug it in the formula, you get the answer. And next time, I will show you how to do this